Uh, what's up, everybody? Welcome back to another stream. I'm reading the entire stream right now because I started a stream and due to the power cut, I had to stop it. Right now, the power seems to be stable and it stopped raining, so let's just give it another go. And yeah, that's pretty much it. And here's what we are working on right now. Eh, there's this dumb triangle which I have, and I'm kind of rendering and like not rendering, printing out the frames per second in my console. And the core motive of this stream is to get this FPS count into this one so that I can have few settings running inside this, if that makes any sense. Yeah, let's just chow from there. Okay, let's see. Here's where I am. The minimal code make to work main.cpp. First, you initialize the window for the rendering, and then you have initialized Dear ImGui context and help the platform to render the binding. You can change the rendering style if you want as well. Yeah, I kind of went through this, and there should be a part where I have to mention what I'm using GLSS version, which should be somewhere. Let's just boop this thing in and go to main.cpp and yeah, key. Okay, unused undeclared identifier init for OpenGL. Okay, why undeclared identifier? What do you mean undeclared? Didn't I declare it somewhere? Okay, that's a cunt way. I mean, is there an example code somewhere which I can pull? Where am I deploying this? Main.cpp. First, you initialize the rendering bind. Yeah, I get that. I get that. Do I need to import something more? Should probably find an example somewhere which would make more sense, and this should probably be version 330, somewhere like that. What's the version I'm using? 330. Yeah, and yeah, it should be true for this. Okay, there's a no use case for it. Do I need to look at something like yeah, how to use uh you know hmm. Okay, okay, include should contain this too. That's my bad. But this doesn't exist because include slash. What do you mean? Ah, right. Hmm. Yeah. Ow, my bad. Hmm. Not found. What do you mean? Ow. The fuck do you want, huh? Yep. I just need to do include and ImGui here, and probably include ImGui here, and there is no wait, file not found. include. Let's just go to include and just say ImGui. And in backend, what am I trying to search? Uh, the fuck happened? Okay, it went blank for a minute. I gotta get my habits back. Yes, can just go to main.cpp now, and yeah, inside include. If I go here, if I search for what I'm doing, ImGui dot impli. Okay, what am I searching? glfw dot h. Okay, and what am I searching next? Open gl3 3 3. Okay, open gl3.h. Yeah, I can find them. Fine. uh do I need this? Include, just say include ImGui, and yeah, backends, and ImGui implement. I need what? glfw first. Yeah, what do you mean not found? um I gotta go to my cmake. Now this one, cmake text. Wherever I have include, include. Yeah, and glfw, where am I using? Glad. Mm-hmm. 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 Man, C++ is too tough to maintain right now. Where do I add? Are you really sure? Like you can't find this? I'm just adding that there, and there seems to be doing fine. Yep. I guess that's something that's fucking with my system for a long time. And yeah, I find in it here, and yeah, probably that. And yeah, it should be version 3. Okay, cool. Main loop. I need this. Start a new frame. Let's start a new frame after, before drawing a triangle. Just format this, and let's begin this here. I mean, too much copy pasting, I know, but what do you mean my float is not declared? My float. Hmm, I don't remember declaring it anywhere too. Ampersand my float. Am I referencing something here? Okay, slider float, and let's just go with this shit for now. I'll fix the bugs later. And I'll just fix the buffer later, and probably destroy this. Mm-hmm. And yeah, delete them. Where is my float? And what does slider float do? Okay, what does this need? It needs a float which is character side float uh, float float v min max. Okay, can I just write a float here? Parameter float with a r value of type float. Yeah, I need my float. Where is my float declared? My float example I should have declared. Fuck man. So you're telling I just need to reference a float variable? That's fucked up. Just need to write a float in my main. I can just do it here. Float m equals to my float equals to what 0.5 f. Okay, and probably should go to my float again. Okay, which is declared right now and shouldn't cause a problem. And if I somehow make run, yeah, okay, no such file or directory. What do you mean no such file or directory? Um, oh, my bad. Oh, just that if I get into this, I kind of need to get it back. Weird. I'm kind of fixing the dependency for the dependency. Can I? I don't think so. Hmm. Okay, that's fucked. These are also just the specifications. SDL3 no GLFW with OpenGL3. Yeah, main.cpp. Here's the shit for it. Here's the shit for it. Like, is there a make file? Make file, yeah, make him, yeah. Baby, let's make. Mm, mm. Execute source main.cpp and oh yeah, baby. Pisses me off. C++ really does piss me off sometimes. Mm. Mm-hmm. OpenGL.h and you can't find. Somehow you can't find. Mm, can't find. Hmm. The paths aren't set up correctly in your project. Let's fix this by step. Okay. Main ImGui. Backend is here. I know one layer inside. So modify your CMake. Include directory CMake ImGui Bakand. Add libraries. Ow, gotta get the libraries in. Okay. CMake. Okay. I don't know if the paths are that mandatory in this, but yeah, this makes sense. Include directories. Again, not just to be include. I mean, I already have include. Target include directories. Well, let's just, you know, do it. Why not? I mean, it's pretty dumb choice to make it. Okay, what's the problem? Can't find imgui.cpp. This is just sad editing, I know. But not fucking target name is reserved and not valid. Yeah, fuck you. Yes. What's the problem now? Error CMake list, can't find the source file. Include ImGui. Include IM. Yeah, probably still will end up sucking this entire part out. Fuck in hell. Error. Okay. Undefined reference to create context. Okay. The linkers are not functioning properly, probably. That's the shittiest part of this. I gotta work on those stuff, man. The main problem here is undefined reference. Yes. Create context. Main. Why? Even now you can't. Okay, that's fucked up. What do I do? Target libraries. You can just add in. Yeah, I can just go CMake. I mean, I'm not good at CMake. I'm really not good at CMake, so probably I can use all the help from ChatGPT for that. I mean, target what? Target link libraries. Glad I'm going to. Let's make. Awesome. I get my dumb triangle though. Where the fuck is my window? Is there any error that I see, bro? No. Build. KDAR build. Okay, and I'll go cd into build. Make. Okay. And is there something that is breaking right now? Warning is for the project developers to surprise it. OpenGL preference has not been set to GLVDN or legacy so far. Compatible with C make, okay. Make. Mm-hmm. Mm, okay. Fuck it. Probably now where I am. Yeah, here I was. Yeah. Main.cpp. Mm-hmm. Mm, where was I? Okay. At least I'll close my mouth off a bit. Okay. New frame. My debug window. I was supposed to get something good, but fucked up. How do I debug it? Let's try this. Where's a triangle? Gotta do it before the triangle. Mm-hmm. Just after using GL clear. Okay. What the name of this? No errors so far, or the errors are being suppressed. GL bind vertex, and when the vertex array is done, then I print. Yeah, there might be memory. GL viewpoint, GL viewframe buffer. This is the part. GL swap buffers Mandala. Sorry if I'm going out of context. I'm speaking in Telugu for a bit, but I'm very pissed right now to get this thing sorted out. Mm, yep. Finally got it. Hmm. Can move this around. If I can do that, I can just come here and where am I passing in the data? Yeah. Get a button. Hello. Begin demo window. Button. Instead of button, can I get small button, invisible button? Sure. Text bullet open URL. I need a text. Hmm. Where am I? Text label. and it will take in a pointer to label fmt. Not really sure on the fmt part. uh, Formatted raw text. I don't think so. mm, let's say for example we want to change the triangle's position, orientation and color. That would be as simple as calling some slider and dark color picker and passing in the data. Okay, wait. Begin. Yes. Slider rotation. Rotation, and I'm giving. Okay. Mm, oh, that's crazy. Hmm. I don't need any of that for now. Hmm. Oh, it's pretty washed out. Hmm. Mm-hmm. I don't need to do all these things, but I just need a place where I can show my slide float and rotation. Can I get this? Ampersand rotation. Rotation will be, yeah, static float. I just need something of this, but I'll explore the library a bit more. But just let me get this one down. Hmm. Mm, undeclared PI. What's PI? PI. Why does it sound like pi? 3.14. Is it 3.14? Hmm. If I make and open this. Okay, the accuracy varies a bit, but I get the sense. Hmm. What's PI? Nah. Yeah, that's messed up. Is there a pi kai somewhere like um pi should be 3.14. That's what I know. Okay, fuck you. But wait. Oh, I can just call in pi value m dot pi. Hmm. In C math. SPI constant in C++. Math dot h. And if I pull this value down, I don't need math library in this case for me just to test out a theory. I just need to do this, and if I make this one and if I open up AGL, uh not AGL, what's the weird fucking part is that? Okay, that's a movable into. What's the dimension set to? It's from 0 to 6.28. That's weird. And why is it 0 to 6.28? Does it make any sense? No. Can I just add this 2 in, and if I make make part is done, run. If I save what I'm arranging now, 2 and 1, I can just do all this value. But pi y, not sure. But my core objective of this thing is I'm making a slider float and I'm displaying a text there, and I can just use im. Sorry, where's the documentation? Hmm. Isn't there a documentation place where I can just refer a bit more about it? Basic controls, probably. Uh, Box, yeah. Button, not sure. Uh, Position, sure. Um, Label. Mm-hmm. Label, label, yes. Unity documentation. Oh, no hacker news, man. No hacker news. Wiki. Okay, debug tools. Okay, debug tools. See debug tools. Wiki explains show metrics window. Show debug log window. Show ID stack tool window. Error handling wiki page. And I'm kind of curious to look about this. Mm-hmm. Okay, this is how debugs are built, or is this something that I'm supposed to build from scratch right now? ILO shows an error message when multiple items have conflict identities set. GitHub ImGui issue 6 item picker. Fine, I just need a documentation for this. Where's the bloody documentation for this? General documentation. Where is general doc? Okay, demos and examples. Folder contains standalone. Dear ImGui test engine. Dear ImGui test suite. Okay. Master bench debug tools. Rendering text and image. Um, Fountains text. 3 types. Okay. Uh, okay. Mm-hmm. What's this? I don't know what the fuck it is. ImGui text probably. Okay. Yeah. Well, let me just go into text and probably need to give. Okay. Just come in here. Frame count. Okay, I just need to convert it to here. Mm-hmm. Value to take in equals to frame typecast. It's been so long. frame count. Will it taken? Yeah, it taken. And I'll just send the reference to value. Yep. Format string is not a literal string. Potential insecure fix available. Probably. You just need to get the string done first. And I'll end ImGui here. And hmm. Mm-hmm. Mm. What's the display? Nope. Mm. ID start string to ID stack. We'll hash the string. Button, small button. We get main. We get text. Mm. Bullet text. Display. Okay. Text disabled. Mm-hmm. Mm. Just ask this guy. Mm. Mm. Probably it'll get the context. Mm-hmm. Mm-hmm. Text. Okay. Score. Okay. If it's that easy, I don't know, man. Is it? Should I just write something like this, and I can just mm, in percentile d, I can just do same count, and if I make, I should see no warnings. Okay. Hmm. Mm-hmm. Mm. What's this? Mm. Can just do this. Okay, that's sad. When I could I'm gonna get info. I can just do that. If I can get the info out from here, it doesn't make any sense to use uh, this demo window. Not demo window. That's what I wanted to do, though. Can I end the loop when I do this? Will it make sense if I do that? Oh, core dump. Gotta end it here, so I just saw my. Okay. Sorry. Make first and OpenGL next. What the fuck is your problem? Make open. Why is my streaming window getting in between this? Sorry. Make. Yeah. Let's make and let's print OpenGL. Uh, okay. Okay, my legs hurt bad. Wait. Ah, okay. Hmm. Should probably get other stuff. Why is it interfering with this? Now it's on the track, on track. But yeah, I want the update to be done when value changes, not when things go bad. Hmm. Can't I just? Yep, does the same work. What did I fuck it up? Where did I fuck it up last time? Oh, by taking out the end, I guess. Hmm? Probably think so. Miyama. Hmm. Hmm. Okay, let's see. How do I make sure that frame rate is updated? But um, how do I make graph or history buffer for a variable too? Okay, plot lines not needed. How do I make sure? ANSTEAD of um between the frames make it look smoother and constant. You can average the FPS over a few frames. Here's how you do it. Oh yeah. Oh, I should just wait for few frames and then display it. Ah, instead of that, I can just do this bullshit where it plots a graph for me. Undeclared num samples. Num samples. So where am I getting num samples from? Num samples. Num samples. Num samples being altered somewhere. Yes. Num samples and FPS samples. Okay, let's just get this done with. I want a good one. Okay, but if I'm writing something, I just want it to make sense, ma. Okay, wait. Make a clean. Make a run. I want a goddamn graph. You said graph, you give me graph. Yeah, you give me graph. The graph should look good. It's varying between. Okay. Can't I just fix the size of my window? Plot lines. Null pointer. Vec. FPS graph. 144F. What does plotline do? Okay, wait. Data plot lines, histogram, plot lines, histogram. I mean, the requirement sheet is like weird. Okay. Helper, there are many shortcuts. Okay. Begin menu, end menu bar. Send a menu bar to current window. Set tooltip. Begin tooltip. Begins. Begin tooltip. Okay, set tooltip. Looks like a fucking mess. I mean, if all I need to do is find examples, I don't know, man. I mean, it takes time to be good at this stuff. Not wrong though. Takes really long time to be good at this. Let me find users of ImGui. Okay, that's a really long video. Let me find. How and why? Please make it short. I don't think nobody is viewing this, but if someone is viewing this, I'll just let this audio sync in by doing this. Boop. Yeah.
And things you need to know about it and what it can do. And that's mainly going to be the first part of this video. The second part, we're actually going to code up an example from scratch just so that you can get a better understanding of how to put it into your project if you're newer to this sort of stuff. Alright, so let's have a look at ImGui. I want this to be an all-inclusive video that covers as much and as broad as possible in a short amount of time so that you have a great jumping off point if you're new to this, or have a better understanding of things if you're just trying to understand more about ImGui. A Google image search of ImGui reveals some popular use cases and examples. I would highly recommend checking it out if you're questioning whether it's the right GUI.
I mean, the audio is pretty fucked up, so I can just go 1.5 is fine. Yeah.
For you. And also I have a few video links that I'll show you shortly, but let's look at some of these and just kind of take in the options available.
Okay.
As you can see, Ubisoft uses it for development of their games sometimes, but they also have a game UI that ships with that. But you can see the developers are tracking things and modifying variables with ImGui. Wow, you can just do so much. Really, for me to get into this, it's going to take way too long to tell you every little option. Pretty much all the main features of a UI that you would want, you're capable of. From text to buttons to radio buttons to color pickers sliders, drop downs, you name it, ImGui can do it. So if this is the kind of thing you need to add to your coding project, I'm going to show you how to do it with, well, pretty much anything. But let's look at a few more sources just to explain why ImGui is so good and why it is so popular. I'm willing to bet most of you have heard of Casey Morituri. He's a programmer. He does a lot of content on YouTube, so you can look him up. But he's been doing this for a long time. And he tends to generally know what he's talking about if he tells you he knows what he's talking about. And in 2005, he wrote an intermediate mode graphical user interfaces blog and did a video on it that's about 40 minutes long. In this video, he covers a lot of the kind of why you would use this type questions. So I'd highly recommend that if you're still questioning why you would use ImGui. But you can see in just a conclusion about it. If you're arguing about it, you probably don't understand it very well. There's not a lot to argue about, which is a very high thing to say of it. And why would he say that? Well, you can watch this and kind of get an understanding. But basically, it is incredibly efficient and it doesn't take much work. One of the main features of ImGui is that it attaches to whatever rendering backend you set up. OpenGL, Vulkan, DirectX, and a bunch of the in-between. It can attach to any of them with special, what they call binding files. But those are essentially just little functions to set it up to what you're currently using. We'll talk about bindings more here shortly, once we get into the walkthrough. But the point of that is, since it binds directly to your graphical interface of choice, or your graphical rendering setup of choice, it's already incredibly efficient and doesn't have much overhead. So enough of these screenshots. Let's look at where you can learn this. One great source I found that was incredibly helpful was a article and a video by, what's this guy's name? Jerry Widless, who works for the Conan team. Now, Conan is a package manager that helps you install libraries, kind of like VC Package Manager and a whole bunch of others. There are quite a few of these, but Conan is a cross-platform one that is pretty easy to use. We tend to use VC PKG on this channel a lot, but we could just as well use Conan all the time, and it wouldn't be a whole lot different. So he does have a video here that goes over the basic setup of ImGui.
And welcome to another screen.
And it is quite good. It's only 6 minutes long. It tells you the basics of getting it going with OpenGL and provides some code that has it already ready to go for a jumping off point. So if you kind of just want to get going quick, this would be a good video to just watch a couple of these sections here. To kind of cover the elephant in the room, or to point it out, there are a million different options for how to get started here. Like we already sort of talked about, you can use any of these package managers. If you're already using one, great, just run it to install and get it set up. These are just two of them, but there's literally so many package managers that it's impossible to keep track of them. But there are a few core well-known ones, so I would recommend using one of those. You can find ImGui on GitHub. You can do a search for Dear ImGui or ImGui, but generally you're going to look for the most popular one by the actual developer. I guess it doesn't have Dear in front of it, I'm not sure. There it is. By Okranut, I think that's how he says it. This is the main repo, and it is the main source. Okay, so let's talk about what we actually need from here, and a little bit about how it works. So we're going to see in here some examples.
Just so that I know, like, yep, that's what I thought. There's a 40 minutes video,
That's
let's watch
backends.
it.
That's mostly what we want. The backends are what handle setting it up for whatever you want. These are what they often call bindings. So you can see there's OpenGL ones, and there's a bunch of other stuff, DirectX, GLFW. If you're using GLFW and OpenGL, you just grab those. That's all you need. You need these few files. Now, you don't absolutely need these, because you can go take a peek at them, and you can see exactly how they work. They basically just run this function, so you can go look at this function. And these are things you've probably done before while getting rendering up and going. Okay, so that's the backends. There's examples. Well, where's the source? I think it's just right here. imgui.h. This has all the main code, and I'm not sure exactly where it's at, but basically you'll see in here some very basic shaders. It handles all the shader backend. They pretty much just use little squares and a couple triangles to do all this stuff. Also, while I was doing research here, I learned that there is a Granny Animation Studio, which is essentially, I think, the animation setup that got pulled into Unreal Engine, because it's now owned by Epic Games, Rad Game Tools. But this was mentioned in that Casey Morituri article where he said he was working on an interface for this, and that's when he got to the intermediate mode stuff. And then I started looking at this and realized, hey, it got bought by Unreal or whatever happened. I don't know. Pretty cool stuff, though. It's neat to see that other people work on stuff and get their tools kind of bought by big companies if they're that good. So it's just inspiration to try to be better and don't worry about all the other things. It's all about how good it ends up being. But with a good interface, your tools are much more clear and you have a much better shot. Okay, back to ImGui repo here. So you could clone this and use it that way. And there are some tutorials down through here of how to kind of get it working. But let's go ahead and just code it up from scratch. Management. I'm going to go with C.
Sure.
Main. Good. And that's, let's give it some proper endings.cpp. Put pragma once. We need to set it up with our project here. There are multiple ways to do that. And I've covered this in other videos, so I'm not going to get into it in GitHub. Well, use Conan in that video earlier explained. We need, and last but not least, we need some dependencies. All the files that we specified from the JSON. It tells you how to use them. Oh, let's go back to wherever that was. We need to see the list. Oh, it's down at the bottom, output. Okay. Yeah, there's some errors in our code. We already know that. But we basically need to put these all in our CMake files. So we're just going to copy those. Let me just dock this maybe over here. And we'll close this thing. All right, so we go to the project we want those in, and just put them in here. We can put them below. And we can get rid of all these comments if we want. They're just for new users in case you don't know what this stuff is. But that's beyond the scope. All right. Why doesn't it let me delete line 1? I don't know. There it goes.
Okay. Wait.
Just going to copy those. And, okay. Installed. And as I hit glad, which brings in OpenGL headers. Okay. So now when we go to build our project or go to generate our project, it's going to grab these libraries from VC-PKG. This should happen automatically as long as you have VC-PKG installed. And as I hit generate there, some stuff starts happening. And it begins grabbing all.
Just give me a minute now. I need to search something up real quick. I mean, it takes too much effort for me to do this, and if there's an easy way for it, why not? Come on, man. Manager for a package manager for C++ package manager Windows macro. Designed to develop manage simplifying the process of finding and installing building. Okay. Get started. Fuck no. Okay. Okay, I'll look at it after some time. First, I need to complete this.
All the files that we specified from the JSON. It tells you how to use them. Oh, let's go back to wherever that was. We need to see the list. Oh, it's down at the bottom, output. Okay, all right. Comments if we want. But what should happen is, yes, that would help a lot.
CMake.
We're seeing some more errors. And then we need a .h for this. So we're going to build this in a little class of save an Exodus file. And now you'll see in this dropdown we have an x64 release. And you can go and see all these libraries, of course. This is sort of on now we could do this in a lot of different ways. I'm just going to do
It's fucking boring. I mean, it's not that boring. It's just that I'm too. I mean, I have a really short attention span for it. Come on, let's go a little bit faster, little bit faster, little bit
Do
faster.
it directly from the Conan page that I showed earlier on. So essentially, we're just going to use a little bit of this, and you can see as a main with the setup window, this should work perfectly fine for us. So we're going to get up to, I think, about here, and that's where things start to change for us. Init GLW. I'm going to get rid of this Apple code because I don't particularly care. And set the context with glad. The easiest way to do this is, well, we're going to get rid of this code, is to just use the glad loader to get the project with an current plane. It will probably build, but it's probably going to say undefined functions. That's because this allows for later expansion. And as you okay, at this point, we are ready to initialize, which means we need to bind it to OpenGL. Now, the ImGui code, which we can go look at here again. Let's open this out folder or check it out. Open in File Explorer, and we have the installs. Now, the install is possible. So there is some info you can find online about. Essentially, you're going to have to use whichever binding you need to grab that. You can also just the dependency. You can see set along as well. And with this, ImGui should start to become useful for you.
Yeah, it does make sense, but I don't know what I should build. Hey.
Hello ladies and gentlemen, it's Mike here at Game from Scratch, and today we are talking about Dear ImGui. Now this is an open source UI library, C++ based, used in all kinds of games, game engines. When we look at who's behind this, you're going to see an absolute who's who of game development houses. And there's a reason for this. It is a open source, cross-platform, immediate mode UI that has a lot of advantages to it. The other thing is it is completely and utterly open source. So what you're seeing in front of you, this is Dear ImGui, and this is the example project. There's available for a number of different backends. Backend concept is pretty important. So you got things like OpenGL, DirectDraw, SDL, etc. It can be available on the back end or Metal, you name it, and it kind of decouples the front end user interface controls from the actual implementation. But everything here is ultimately just drawn out to a frame buffer that you draw to your back end of choice. So the back end part isn't exceedingly complicated, but there are a number of them provided for you. So here you can see the example project. This is the Vulkan example, so it uses the Vulkan back end. All the different examples are basically identical. That's the entire idea behind it. It decouples the one from the other. You can see what it is capable of here. Here's a simple hello world. Here is a layout example. You've got things like tabs, you've got lists, you've got menus, you've got closable windows. Here we got a slightly more complicated example with the document in place. Here you've got custom rendering examples. We got things like slide bars and drop downs and things like constrained sized windows. We have simple text overlays like this one right here. Then you can just dump some information out if you so need to. We got an example console right here. So it gives you kind of an idea of the capabilities of ImGui. The nice thing on top here, there's a number of different examples you can jump through and take a look at. So if you want to look at manipulating window titles, you can do so there. At the same time, it is also completely themable. So you see here, I come in, we can switch to a dark theme, which we're already in, classic theme, or okay, shield your eyes, the bright theme. All right, back to dark, back to dark. There we go. So you see here, you've got control over all of the different settings for it. All the different things can be themed and colored. We can, control pretty much how every single thing looks, and you have control over that as a programmer. So now for the demonstration, let's actually jump over to the website. And here we are. We are on GitHub. This is an MIT.
Just give me a minute, like, where was I in the code? This is fucking painful. Yep. I want number in the end. You know what? Fuck it. I want number in the end. Do that. I am GUI, and I'll just say text. FPS number percentile D is equals to what? FPS sample AVG FPS. Where is my float number, ma? Or do I have to make it again? Make a clean, make a run. Otario, build it. Draw, draw, draw. Let's go. Yep, finally got something on. Which make really sense. Which make real sense right now. See? Voila. I mean, 60 frames per second it's fine, but I tested the same thing in my Mac. It's somewhere around 100. Mm-hmm. 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 Its decompiler has been overridden. What do you mean? What do you mean, ma? Something wrong with you, bro? Yeah, fuck you. I mean, there's a point where I need it, but right now, I don't know. How long? 179? Bad, man. Let's just say we are cool for now, okay? IO stream. Are you fucking kidding me now? If the window is not GG, then I'm not really. It's doing good. You're saying not good. What the fuck, ma? Okay. I'm kind of hoping that I'll write something more there. If you know what I mean. Mm-hmm. Let's see.
Licensed project. That means you can use it pretty much however you want, just waiving them of liability. It is a bloat-free graphical user interface library for C++. It outputs optimized vertex buffers that you can render anytime in your 3D pipeline-enabled application. It is fast, portable, render-agnostic, and self-contained with no external dependencies. That's actually really nice. So you don't need to resolve 1,800 million things. You don't need this zlib library or that font rendering library or anything else. Literally, you just need Dear ImGui and a back end. It is designed to enable fast iterations and to empower programmers to create content creation tools and visualization/debug tools, as opposed to the UI for the average end user. It favors simplicity and productivity towards this goal and lacks certain features normally found in more high-level libraries. For example, you probably don't get drag and drop or cut and paste, some of the things that you kind of take for granted in your traditional, WinForms or that kind of thing front-end user interface. Dear ImGui is particularly suited to integration into game engines for tooling, real-time 3D applications, full-screen applications, embedded applications, or any app on consoles where the operating system features are non-standard. And that is actually really key. If you're trying to create something cross-platform and you want to have a text field or tabs or list items or even just straight text output, well, when you're on Windows or Mac or whatever, you're probably going to have, the Win32 API provides you a UI library. The Mac provides you a UI library. Android does, iOS do, etc. And then there are even libraries out there that sort of layer over top of those to give you a common programming interface. But when you get over to the Switch, to the Xbox or PlayStation, there are no UI libraries. You've got to do all of this work yourself. And there's where Dear ImGui really kind of shines. Probably why it's so well adopted. As mentioned earlier on, there are a number of backends. We're going to look at that in just a second. But now we're going to get to here is a simple code example. So you can see here it's saying ImGui text to make the hello world text appear. If you press the save button, run the save function. ImGui text input, we create a text field there and a slider field. And you see the immediate results right here. disappear. Now, immediate is an important word. That's where this comes in. There's two kinds of user interfaces. Retained mode, which is what your traditional like WinForms and .NET kind of thing are, or this is Win32 or whatever you want to call it. Those are retained mode UIs. Basically, you set up a UI and then you run it and it responds to events. Well, with an immediate mode, what you're basically doing is creating the UI immediately. That means when this guy says, ImGui, draw text, hello world, it draws that. It draws that off to the frame buffer immediately. So what this basically means is if you want this to happen in your game, this is happening every pass through your loop. So every time, every frame of your game as it's running through the game engine, you recreate your entire user interface. It sounds cumbersome at first, but it actually, you get used to it really fast. And there are some advantages to that, especially on state tracking and so on, things like that. So you can see a slightly more advanced example of creating an ImGui user interface. Once again, somewhere in your game loop, you call this code every single pass. If you don't, for example, we'll go back to the simple example, if on the next pass through, I don't call this line, this part is going to completely disappear. So that's kind of the overview or idea behind ImGui. Once again, it is available up on GitHub. I will have that in the linked article down below, so if you want to go ahead and check it out. And it is the MIT license, which is very, very nice. Now, it's also sponsor supported. And as I mentioned earlier on, the sponsorship is impressive. So you're going to get an idea of some of the people that are using ImGui. So let's go take a look. We've got Blizzard, Google, Nvidia, and Ubisoft as major sponsors. Plus, we've got Activision, Arcane Studio, .emu, Framefield, Grinding Gears, Hexagon, and Media Molecule, and so on and so forth. So you can see there are a number of different people and then a number of different patrons. If you use this in your project, also maybe consider supporting them, obviously. That is how they continue to develop this one. And if we go back and take a look, you're going to see development happens pretty steadily. In fact, that's part of why we were talking about it. Version 1.80 was just released. We'll get back to that in just a second. Now, as mentioned earlier on, there's two sides to your code. There's the front end, the Dear ImGui library, the header files, CPP files. You drop those into your project, and then you're going to need a back end. Can think of this as a renderer. Now, here you can see they have back-end implementations for a lot of stuff. We've got Allegro, DX10, DX11, DX12, DX9, GLFW, Glut, Marmalade, Metal, OpenGL 2, 3, OS X, SDL, Vulkan, and Win32. So you've got pretty much most of the platforms you're going to want to run this on. There is already an existing back end for you. On top of that, now we get into language binding. So if you're not necessarily, this is a C++ library, I think 90% of the code C++, a little bit of C and Objective-C smattered in there, but if you're using a different programming language, well, Dear ImGui has you covered there as well, because we have bindings for Beef, C, C#.NET, ChaiScript, CobbScript, Crystal, D, Go, Haskell, Hax via CPP, and Heaps, Java, JavaScript, Julia, Kotlin, Lobster, Lua, multiple choices in the Lua thing, Nim, Odin, Pascal, Pure Basic, Python, many, Ruby, Rust, and Swift, and then we get into games, game engines, and so on. Here you can see there are ones for Android, Adventure Game Studio, Amethyst, Blender, BSF, Cinder, Cocos 2DX, Diligent, Ebitin, Flexium, Game Maker, Studio 2, Godot, multiple, GLEQ, GTK, OpenGL 3, IR Elect, Love Plus Lua, Magnum Monogame. Oh, I might be talking out my butt on that one. And then we got a couple of multiple renderers, and then we've got ports or just merged into master. So you've got table layout support. Here is an absurdly tall table in example in action. And this functionality, though, is not considered full out ready. It is beta, which means it might slightly, their emphasis on slightly.
Yeah. Let's just say how to pull info from GPU. No direct equivalent, but Alexa should give you what you want to try. Okay. Ooh, what's this? I want to directly run something in my terminal for us. Command line utility that proves the detailed information about hardware configuration of a machine, including firm. Okay. Let's go. Let's see. Clock 33 megahertz. Buzz physical ID VGF. Vendor Nvidia Corporation description. 3050 mobile. Configuration compatibility bits. I want to see the usage fluctuation. What's with the usage? I have an NVIDIA graphics card inside mine. Okay. How do I constantly call it? NVIDIA समय GPU ने persistence की volatile GPU display persistence processors user lib xorg. What's not using your, okay, let's just divide this up a bit and sorry make done. Okay, now my GG is running. Okay, wait. Okay, I can't type. Let's just keep it here. You can just see it's running. Probably not. Just let me pull it out here. Now you can see it. Okay, let's see. Let's a little bit small. If I have a process involved here, yes, I do have a process involved here. More smaller. 9 MB memory usage, 9 MB 40. Okay. This is kind of causing the headache, huh? NVIDIA G4 RTX. Okay, 9 MB 9 MB. Probably that's the meat. If I cool it down, if I do this now, should get. I'm still getting the same thing. In real time GPU info. How to get CPU in usage in Linux. Value is device number target, since my code is running on device 1, which is ID argument 1. Okay. Similar NVIDIA command discusses about you'll need SSH into the host on which the job executing your GPU code is running. Once the host, you can simplify the run. Command this command produces SMI NV top. Sorry, not npm. Sudo apt install. What's that? NV top. Can I just write yes here? Yeah. I can. Looks like I can. Ooh, baby, yeah. And if I run, what's the GPU strike now? If I run the application, is there a spike? GPU 0, GPU 1, GPU 2 clearly has this. Snap, Firefox, not Firefox. GNOME shell, probably. OBS, yes, OBS will burn this thing up. GPU, but if I cut this out, which one dies? Okay, these are all my processors. One is GNOME. Charlie. So GPU. Okay, let's see. I have mostly this many. I mean, I'm just acting. I might look acting stupid, but I don't know shit about this. So Firefox, GNOME shell already exists. Crashed OBS frames, yes. Alacrity. OpenGL app. How much does testing cost? It costs 2% of CPU, GPU 1%, which is roughly what? It's costing literally nothing to hit. 59 frames watt. Memory is like 1 or 2 MB to render that thing on. But unless I do some kind of activity, just will this cost significantly? I don't think so. Yeah, 1%. 1% of my graphics memory is used on this. Okay, that's a good sign if I'm not wrong. Okay. Okay. I just need to create one more. Let's see where we zoom this thing up a bit. Quit is F10. That's fine. I might need you a bit more. Let's see. Not this one. Let's just go. Let's go. Okay. Let's get back to the shaders. Running should result in okay. If you're stuck, okay. Our own shader class. Writing and compiling, managing shaders can be quite cumbersome. As a final touch on the shader subject, we are going to make our life easier by building a shader class that reads shaders from the disk and compiles and links them. Check for errors and is use. Okay, this also gives you a bit of an idea how you can encapsulate some of the knowledge we learned so far into useful abstraction objects. Okay. We will create a shader. Yeah. Okay. We will create a shader class entirely in a header file and mainly for learning purpose and portability. Let's start by adding the required includes by defining the class structure. Include get to get all the required OpenGL headers. Okay. Constructor reads and builds the shaders. Okay, inside AD. Void use okay, utility uniform function. Void set bool, void set int. Okay. We use several pre-processed directives at the top of the header file using okay. The shader class holds the ID of the programs. Its constructor requires the path of the source code of the vertex and fragment shader respectively that we can store on the disk as a simple text file. To add a little extra, we also add several utility function to these. Okay, use activity, the shader program, and all the set and functions query a uniform location and set its value. We are using C++ file stream to read the content from the file into several string objects. Okay. We are using string stream. Nice. Okay. Let me get this stuff done, please. Okay. Let's just retrieve the vertex. Okay. String fragment code. If we should, okay. Ensure we should file exception bad habits. Bad bit, sorry. Fail bit. So I'm just giving path for it, path v shader file dot open this and fragment shader and string is stream v shader okay, stream and fragment should read the files buffer content into the stream. Okay, then I'm closing the streams. Okay, this dot stream and this dot stream. If the stream failure and do this. I'm moving the code onto it, but next we need to compile and link the shaders. Now that we are also reviewing it, compilation link failed. So print the print the compiled time error. This is extremely useful when debugging. You are going to need this error logs eventually. Okay. Create shader. Shader source. V shader code. GL compile shader. GL shader. Okay. Compile status. And if it's success, hit me up. Okay. Log info. Info logs. Okay. I have care of info logs. Nice. Am I storing something into it? I don't know. Okay, GL create program, and after that I'll go through my usual thing where I GG. The use function is straightforward. Similarly, for any of the uniform setter functions, and there we have it, a complete shader class. Using the shader class, it's fairly easy. We create a shader object once. From the point we simply start using. Okay, here are the stored you can find the source code here and newly created shader classes. Newly created shader classes, how are they looking? Class shader class, GL use program. This is not the main one, but like how am I pulling them? Shader are shaders. Code here. Learn OpenGL slash shaders. I'm pulling them here and I'm doing my GG. Makes sense. Exercise, add vertex shader so that the triangle is upside down. Okay, solution. Specify. Okay, makes sense. Next. I can do this. I know that. But textures. We learned that to add more details to our object, we can use colors for each vertex to create some interesting images. However, to get a fair bit of realism, we have to have many vertices. So we could specify a lot of colors. This takes up considerable amount of extra overhead since each model needs a lot more vertices for its each vertex a color attribute as well. Okay. What artist programmers generally prefer is to use a texture. A texture is a 2D image, even 1D and 3D texture exists. To use to add detail to an object, think texture as a piece of paper with a nice brick image. Example, it's neatly folded over 3D house. So it looks like house has stone interior because we can insert a lot of details into the single image. We can give illusion to the object extremely detailed without having to specify extra vertices. Brick wall map to the triangle chapter. In order to map texture to, we'll need to tell each vertex of the triangle which part of the texture it corresponds to. Each vertex should thus have texture coordinates associated with them to specify the part of texture image to sample fragment interpolation then does the rest of the other fragments. Texture coordinate range from 0 to 1 in x and y axis. Remember that we use 2D texture images. Retrieve the texture color using texture sampling. Okay, texture coordinate starts at 0 0 y, and for the lower left corner of the texture image 1 1. Okay, left corner of the okay. For the upper right corner of the following image coordinates. Okay, I get it. we specify 3D coordinate points for the triangle. We want the bottom left side of the triangle to correspond to the bottom left side of the texture. So we use 0 0 texture to make it, and 0 5 to just get it here. And okay, it makes sense. Here's the texture. Okay, texture coordinates is 0 0 0 to 1, which is this one, and 0.5 and 1, which is top corner. Okay. Texture coordinates usually range from 0 to 1, but what happens if we specify coordinate outside the range? The default behavior OpenGL repeats the texture image. We basically ignore the integer part of the floating point texture coordinate. There are more options in OpenGL. Okay, GL repeat the default behavior for the texture, repeats the texture image. GL mirrored repeat, same as GL repeat, but mirrors the image with each repeat. Okay, that's weird. GL clamp to the edge, GL clamp to the border. Okay. Each of the aforementioned options can be set per coordinate axis. S, T, and R if you're using a 3D texture equivalent to XYZ with the GL text parameter function. 2D, okay. I got to read too much to figure this one part out. But like it's a long read and I'm tired. You understand? It's like people get tired sometimes. I'm not in the flow too today. Yeah, that's my cue for you guys, and hopefully you learned pretty much nothing today. But hopefully I can make it more informative and entertaining the next time when I walk in. And that's me. Peace.